All right, this is our lesson 6.2, solving exponential equations and inequality. This is 6.2 A. All right, the essential standard. I can solve exponential equations and inequalities. That's what we're going to focus on today. And eventually we will learn how to solve logarithmic equations and inequalities. An exponential equation is an equation containing variable exponents. We have exponential growth and decay that we've learned in the past. So the exponent is varying. If the two exponential expressions with the same base are equal, then their exponents must be equal. So if I have some equation where I have b to the x, and that is equal to b to the y plus 2, then since these have the same bases, we know that the exponents must be equal to one another. That's what that statement is saying. So to solve these equations, the goal is to manipulate the bases. We have a base of 9, I have a base of 3, to basically equal each other. We need to get the bases equal to one another. So on the first side, I have 9 to the 2x minus 1 is equal to 3 to the 6x. So what I want to do is figure out how to manipulate one of them to equal one. I can make the 3 a 9 or the 9 a 3. And it is easier to manipulate the 9. So let's take the 9, and what does that equal to? That equals 3 squared. So what I have now in parentheses is 9, because, all right, and then I have that 9 is to the power 2x minus 1, and that equals 3 to the 6x. Now, the rule is that if I take the exponent to a power, I am going to multiply. So let's simplify that by multiplying the 2 by 2x minus 1. So I have 3 to the 4x minus 2 is equal to 3 to the 6x. I now have it in a form where I notice that my bases are the same. And if my bases are the same in this particular situation, then my exponents must equal to one another. So I know that 4x minus 2 is equal to 6x. Now I can solve by moving my 4x over, subtract each side by 4x, I get negative 2 is equal to 2x. I solve for x and I find x to be equal to negative 1. So that is the general approach to these types of problems. All right, B, why don't you try one yourself? Welcome back. All right, the key I think is to recognize the fact that that 8 is 2 to some power. So I have 2x on the left-hand side, and that 8 is essentially 2 to the third power. So in parentheses there, that is 8, and then that 8 was originally to the third power, so I have to include that. Now I've used my rules for exponents, and I find that 3 times 3 is 9, and so the right-hand side becomes 2 to the ninth. So now that I have it in a form where I have the same bases, let's use a different color, I can then set my exponents equal to one another, and we find x to be equal to 9. All right, that's the general approach. All right, letter C. Now I have 5 to the 3x is equal to 1 over 25 to the 2x minus 4. Hopefully you recognize the fact that 25 is the same as 5 squared. Okay. Here, let's write it this way. 1 over 25 is the same as 5 squared. Well, that 5 is on the bottom. I'm getting close. My goal is to get it into this format here. That 5 squared is actually 5 to the negative 2, and now it's on the top. And so now I can replace that 1/25th with 5 to the negative 2. And so I have 5 to the 3x is equal to 5 to the negative 2. So that is 1 over 25, and that is to the power 2x minus 4. So I have an exponent raised to an exponent, and I will then need to multiply that -2 through the entire expression. And when I do that, on the right-hand side, I will get 5 to the -4x plus 8. Please make sure to distribute that -2 all the way through. Now I'm in a situation where my bases are the same. And if that is the case and they're equal to one another, then we know that 3x is equal to -4x plus 8. I can now solve for x. I will add 4x to both sides. I get 7x is equal to 8, and I divide both sides by 7, and I get x is equal to 8 over 7. Why don't you try one yourself? Welcome back. There's two different approaches to this. 4 is the same as 2 squared, and 64 is the same as 2 to the 8th. I'm sorry, actually 64 is the same as 2 to the 6th power. Or you could recognize, so I can get it in the bases equal to 2, or you could also recognize that 64 is the same as 4 to the 3rd power. And if I recognize that, I can only have to manipulate one side of the equation. So I have 4 to the 2n minus 1. And I know that 64 is 4 cubed. So in parentheses, that is 64. And now the bases are the same. So I can set 2n minus 1 equal to 3. So I have to set the exponents equal to one another, and I can solve for n. So I have 2n is equal to 4, and n is equal to 4 divided by 2, which becomes 2. All right. Now we're going to do inequalities. So what we just solved were solving equations that involved an exponential equation. Now I'm going to solve inequalities that involved exponentials. Now here's something we need to pay attention to. If the bases are identical and the bases are greater than 1, you can do exactly what we just did. Okay, so for example, if I have 2 to the 4th, let's say, is greater than 2 to the 3rd, we know that 4 is greater than 3, okay? So we don't have to do anything special if the bases are greater than 1. However, if the bases are identical and less than 1, between 0 and 1, it's recommended that you make both the bases greater than 1, because you will then have a little bit better situation. Let me give you an example. If I have 1/3, now that's less than 1, squared, and I say that that is greater than 1/3 to the 4th, okay? So 1/3 squared is the same as 1 over 9, right? So that's 1 over 9. And 1/3 to the 4th is the same as 1 over 81. Okay, so 1/9 is truly greater than 1 over 81. However, if we were to compare the exponents, we would have to flip the sign, because 2 is not greater than 4. 2 is less than 4. Whoops. So if we have a situation where my bases are less than 1, we should make our lives easier and make the bases, change them so that we can not have to worry about switching this sign. And I will give you an example of that very soon. All right, solve each inequality. So the process is very similar to what we have done in the past. And so we need to get the bases to be the same. And so I have 16 and 8, and I can make 16 the same as 2 to the fourth. 2 to the fourth is 16, and so I will take that 16 and bring it to the 2x minus 3 power. And that will be less than 2 to the third power. 2 to the third power is the same as 8, okay? Now, our bases are the same. Well, actually, let's go ahead and simplify the one on the left. Let's distribute that 2 to the fourth. We need to multiply this 4 times 2x minus 3 using our power rules. So 2 to the 8x minus 12 is less than 2 to the third. Okay, now the bases are the same and the bases are greater than 1. So I don't have to worry about any unusual situations. So we can take the exponents, 8x minus 12, and set them equal to 3, or I'm sorry, less than 3, and then solve for x. So 8x less than 15, and we find x is less than 15 over 8. And that's how you solve it. All right. All right. Now I need to hopefully recognize, and I told you guys I would create a little table that to get your mental math prepared or up to snuff. So what is 243? Well, there's a good hint here that it has to be something related to 3. So 3 times 3 is 9, times 3 is 27. Okay, so 27 times 3 is 81. So there's another one. And then 81 times 3 is 243. Okay, so we know that 1 over 243 is the same as 1 over 3 to the 5th power. Okay, so I don't want the 3 on the bottom because I need to have the bases the same. And so I can move that 3 to the 5th power to the numerator, and that becomes a -5. So I have 3 to the 2x minus 1 is equal to 3 to the -5. And that 3 to the -5 is the same as 1 over 243. And it's not an equals, we are solving inequalities, and this is greater than or equal to. Okay, we're still trying to solve, which means we need to find the values of x that makes this statement true. Because the bases are both 3 and the 3 is greater than 1, I can say that 2x minus 1 is greater than or equal to -5 and solve for x in a way that we are used to. So I would add 1 to both sides, so I get 2x is greater than or equal to -4. X must be greater than or equal to a -2. Okay. Try one yourself. Welcome back. So I have 2 to the x plus 2. There's a hint that I should probably try to get that 32 in terms of 2 to some power. 1, that will be equal to, where's my paperwork? 2 to the 5th. So 2 to the 5th is the same as 32, which I want that 2 on on the top, so I need to switch that sign. So 2 to the -5th is the same as 1 over 32. So now I have my bases the same. 2x plus 2, 2 to the x plus 2 is greater than 2 to the -5th. My bases are the same, and my bases are greater than 1. So I can solve this pretty straightforward. X plus 2 is greater than -5. Subtract 2 from both sides, and I find x is greater than -7. All right. Now, here's one where we could potentially, if we did not follow this rule, where we want to have the bases greater than 1. So what is 1/9? 1/9, I'm just going to go off to the side. 1/9 is the same as 1 over 3 squared. Okay. And 1 over 243, 243 is the same as 1 over 3 to the 5th power. Now, I could solve this, and I'd have 1 third to squared, and I would take that to the 3t plus 5 power, and then I could set that less than or equal to 1 over 3 to the 5th power and take that to the t minus 6. But we would have that situation where my bases are no longer greater than 1, and I would have to switch my signs here. And so what we want to do, this is not what we want to do, okay, is we would like to create such that the bases are greater than 1. So how do I do that? So I have this 1 over 3 squared. That is also equal to 3 to the negative 2. So we are going to replace this 1/9 by 3 to the negative 2, and we will take that to the 3t plus 5. Okay, we will take this 1 over 243, and we will set that equal to 3 to the negative 5th. So we have less than or equal to 3 to the negative 5 to the power t minus 6. Now both my bases are greater than 1. Now I can distribute this negative 2 through, since we multiply, through 3t plus 5, and I will take this negative 5 and multiply through t minus 6, and I'll simplify. So that becomes 3 to the negative 6t minus 10 is less than or equal to 3 to the negative 5t plus 30. Okay, now my bases are the same. These bases are the same, and they're greater than 1, so I don't have to switch the inequality sign. And I can set my exponents, well, not equal to one another, but less than or equal to one another. So negative 5t plus 30. So negative 6t minus 10 must be less than or equal to negative 5t plus 30, and I will then solve for t. I will add 5 to both sides, so I get negative t. I will add 10 to both sides, and I get 40. Is that right? Yes. I need to divide by negative 1, and when I do that, I must switch my signs, don't forget. And I get t is greater than or equal to negative 40. All right, try one yourself. Welcome back. I have 1/2 is less than, I'm sorry, 1/2 to the 4x plus 1 power is less than or equal to 8 to the 2x plus 1 power. I need to get them to the same base. So I'm going to take that 1/2 and I'm going to make that 2 to the negative 1. And that will be taken to the 4x plus 1. And that 8 is the same as 2 cubed. So that 8 is the same as 2 cubed, right? And that, let's make that a little cleaner. That is 2 cubed, all right? There you go. And that is taken to the power 2x plus 1. Then I'll use my rules for taking an exponent to a power. I will multiply through. That becomes negative 4x minus 1 is less than or equal to 2 to the 6x plus 3. The bases are the same, and my exponents are greater than 1. So I can set negative 4x minus 1 less than or equal to 6x plus 3. I do not have to worry about switching my signs, and I can solve for x. I'm going to add 1 to both sides. I'm going to subtract 6x from both sides. I am then going to divide by negative 10x and switch the signs when I do that. And I find x is greater than or equal to negative 2/5. All right, I hope that makes sense. Reach out to me if you have any questions.